Hello friends, if you remember last time I spoke about discovery of zero, and I also made a comment that zero is a real hero in the universe of numbers. Why? Because zero has got some exceptional powers which no other number can ever have. Zero multiplied by anything is equal to zero, but this creates another equation: 0 upon 0 is equal to anything. 0 multiplied by any number gives you what? 0. But if you write it, it also means 0 upon 0 is equal to anything. Now anything can be anything, because you can write it 10 or you can write 100 also. In that case, we'll come across a fantastic contradiction that 10 is equal to 100. That's not possible, because if you give me 10 rupees and ask for 100 rupees back again, I will be in a dilemma. Okay? So, therefore, this operation is critical. I mean, it cannot be performed properly by normal arithmetic laws. Okay? I told you that one of the greatest villain of all times as far as students are concerned is that great man called Sir Isaac Newton. Sir Isaac Newton realized that he must find the solution to this problem, because otherwise this calculus itself will not be in existence at all. Now, he did one very fantastic concept he introduced, and that concept is called limits. Okay? So, today's lecture is all about limits. Limits. Okay? Now let us look at, my entire endeavor or objective of teaching mathematics on this platform is, my tagline is, mathematics is nothing but common sense. Unfortunately, it is found that common sense is rarely used in the reality. So, it's a mathematics is nothing but common sense, which is highly uncommon. Correct? So, I am going to reduce this concept of limits to common sense. I mean, very simple. For example, I will give you one example, very simple, that one student who is studying in 12th standard, he has gone through several earlier examination, preparatory examination. He has passed 10th standard, he has passed 11th standard. He has passed 12th standard first semester. He has passed a elementary or preliminary examination of, which prepares you for the final examination. So he has gone through all these examinations, but still he is very, very doubtful about his success. So he comes to me and he asks me, "Sir, what do you think will be my marks?" If I tell him, wait till the results are out, but that he knows. The wait till results are out is not an answer he is looking for. He is asking me, can I predict his answers? So he is not interested in actual result. He is actually interested in predicted result. So can you understand? So prediction and actual value, I may predict that he has got, okay, you have got, say, so, and when I am going to predict, I am not going to ask him how many marks he got in KG. That is irrelevant. But I will start asking him questions near to 12th standard examination. That means what? I will start from, say, let us say 10th standard में कितना marks मिला बेचारे को, हाँ? अच्छा 10th standard के first semester में कितना मिला, second semester में कितना मिला, then आपको 11th standard में कितना marks मिला, 12th में कितना मिला, then the 6 monthly exam में कितना मिला, then in the preliminary examination में कितना मिला, and I will go closer and closer to that number to which he is looking for. And based on all these numbers, I may say, it looks like from your record that you will get around 80% marks in the 12th standard exam. So this is a predicted value. It's a prediction. It has nothing to do with the actual value. In reality, how do you know? He may fail ill and he'll get 0 marks. Correct? Or he will actually get 80% marks. Or he will get more than that. Okay, so actual value has nothing to do with predicted value. Predicted value depends upon the observations you are taking before the event happens and in the vicinity. That means in the nearly neighborhood, not far away from it. So you go near and nearer to that 12th standard examination, and till then you find out what is going to happen, and that is called predicted value. So there are two values, predicted value and actual value. Now let us apply this example to mathematical function. So I am telling you that there are two kinds of values. One is called predicted value, and actual value. Let me give you another interesting example of these two things. There's a war going on between India and Pakistan. Let us imagine. And just imagine all those, aeroplanes flying very high, making a lot of noise and all that. And there is a radar, and there is a radar operator who's watching the Pakistani airplanes attacking us. So he suddenly realizes that there is one particular aircraft which is traveling at the speed of, let us say, 100 kilometers per hour for last 40 minutes. So you will calculate 40th minute, it is what? It is 100 kilometers. Then 41 minutes, it is 30 kilometers. 42 minutes, it is 100 kilometers. 43 minutes, 100 kilometers. So he now says that whenever it will reach Indian border, according to his calculation, the speed of the aircraft may be 100 kilometers per hour. That is his prediction. Is it guaranteed that it will fly at 100 kilometers per hour when it reaches Indian border? No. Might be that Indian missile hits it and the speed will become 0. So actual speed was 0, whereas the predicted speed was 100 kilometers per hour. Correct? So this has got a practical value, practical applications, right? So predicted value, I am going to denote, in short as PV, predicted value. And actual value, I am going to denote as what? AV. Actually, this is what actually happens. Okay. Now, every function, for example, in mathematics, you must have learned mathematics uses a language of functions. Functions means what? There are two variables, y and x. There is some kind of a relation between the two, so that if I know value of x, I can calculate value of y, right? So there is a relation. This relation is indicated by a symbol called fx equal to, okay? Y equal to fx. This x is called, in calculus, independent variable. Independent variable. And this y is called dependent variable. For example, suppose you are heating water, then temperature will depend upon the amount of time for which you are heating. So temperature will be y, and independent variable is the amount of time that you are spending, right? So that will be a function of temperature, will be a function of time. So time is independent variable here, and temperature will depend on how long you are heating that particular water or whatever the space is. Okay. So it is very clear why it is called independent and why it is called variable. Variable means what? This is a symbol. This symbol represents, it's a representative, like we select, our MLA, as a representative of our entire constitution, our entire ward. In the same way, X is a representative of certain set of numbers, and those numbers are included in called domain. So X belongs to some domain, and then Y is also representative of some number. Value of X keeps on changing. You can substitute any value in place of X, provided it belongs to its domain. Okay. So that is why it is called variable. So it can be replaced by 1, 2, 3, 4 if these numbers are there in the domain. Okay. So this is dependent variable. Now the function could be let us take a very simple function. Let us say y is equal to x plus 1. See how easy it is. Y is equal to x plus 1 means what? You give me any value of x, I'm just going to add 1 to it. That's all. That will give me y. So if x is 1, x का वैल्यू दे दो 1, करेक्ट. तो y का वैल्यू क्या आता है 2, करेक्ट. 1 + 1. अगर x इज इक्वल टू 2 है तो y का वैल्यू क्या आता है, y का वैल्यू आता है 3, करेक्ट. So this is 1, this is 2, like that. So when x is 1, y is 2. When x is 2, y is 3. So now I want to find out what is the actual value at x is equal to 2. What is the actual value of x is equal to 2 of this function? It's very simple. You just put x is equal to 2 here and you will get actual value, right? So actual value of this will be y is equal to 2, 2 plus 1, correct? So the answer is what? 3. Very simple answer. So actual value calculation में कोई problem ही नहीं है. Very simple. All you have to do is get the formula for the function and substitute the variable, independent variable value at that point, and you will immediately get actual value. So actual value is very easy to find out. Now, I am not interested in actual value. As I said, the student was not interested in how many marks he actually scores. He was interested in what? Predicting the marks that he will get in 12th standard. So I am not interested in what is the predicted value. PV at x is equal to 2. Now, because it is prediction, I am not allowed to substitute 2 because that will become actual value. Whereas I can substitute values, but those values which are very near to what? 2, correct? So let us start. Suppose I take x as 1.9. Let us take 1.9, okay? Then you take 1.99, okay? Then you take 1.999. Then you take 1.9999. Remember, all these values are very, very significantly close to 2, but still they are not 2, correct? And I'll calculate the value of the function here. What is y? If I put 1.9 here, all I have to do is add 1 to it. So y will become 2.9, correct? Y will become 2.9. Okay? Then it will become what? Then it will become 2.99. Then it will become 2.999. Here it will become, so it will be 2.99, correct. So this number is approaching, you can clearly see 3. Now see, as we go very close to 2, the value of y goes very close to what? 3. So therefore, I say that predicted value at x is equal to 2 is what? Y is equal to, y is what? The value is what? 3. So y is approaching 3. So if I want to write, symbolically, it means x tends to, matlab it is approaching towards what? 2. Then y seems to be approaching towards what? 3. Therefore, predicted value is 3. Predicted value is 3. Now, in this example, actually, actual value is also 3 and predicted value is also 3. But remember, this is just a coincidence. Every time it may not happen. In this example, both values are equal. Why they are equal? I am going to talk about it little later. But every function has got actual value and every function has got predicted value. Now let us come, why you will be wondering, sir, actual value, predicted value same है, ये इसमें ही मिल गया तो ये सब लफड़ा करने की जरूरत क्या है? जरूरत है भाई, क्योंकि हमको sometimes actual value मिलता ही नहीं है. There is no possibility of arriving at the actual value. In that case, we have to take satisfaction only with what? The predicted value. Okay. Now, where and in what situation you come across that? Obviously, you know that last time we have discussed the power, the complications that power of 0 has created in the world of mathematics. So in order to solve that puzzle, we are going to use this concept of predicted value. Okay. Now let us see that I gave you one example where actual value was 3, predicted value was also 3. So it looks like this entire exercise of finding predicted value is useless. It isn't. Why? Because I told you actual value sometimes becomes impossible to calculate. For example, let us take slightly different function. Slightly. Actually, it is the same function, but it is slightly different from the one we have already discussed. So that is what? So I'll say there is a function called x square, x square minus 1 divided by x minus 1. This is the function. Okay. Now this function, suppose you are asked, find the actual value at 1. Find actual value at 1. Correct? So you know that actual value nikalne ke liye all you have to do is just put x is equal to 1 in the formula and arrive at an answer. So you will get like this: 1 square minus 1 divided by 1 minus 1. But this gives us an explosion because this value is 0 by 0 and I cannot find out. So it is very clear that this function does not have any value at x is equal to 1, because there this function's formula reduces to perennial problem called 0 by 0, and I wanted to find an answer to this question. So that is why I am saying, okay, chalo, predicted value तो नहीं है, actual value तो नहीं है, predicted value निकाल के देखते हैं क्या होता है. Correct? So no actual value. Correct? So no actual value. So does it have predicted value? That is the question. Correct? That is the question. But I know predicted value can be found out by approaching the number 1, because you want to find out actual value at 1. So don't substitute 1, but be very close to 1. Okay. So let us take values which are very close to 1. So let us take, I'll just write here a data that x will first take 0.9. which is very close to 1 because the difference is hardly 0.1. The next value of x will be 0.99. Very close to 1, right? Then I am approaching 0.999. Then I am approaching 0.9999, and this will go on. You know, this is a infinite process. But this process will never take you to 1. But we are going closer and closer and closer to 1. Because if you take this real line, right? And if this number is, let us say, 0, and if this number, let us say, is 1, then 0.9 is somewhere here, 0.99 is somewhere here, 0.999 will be even closer than that, and 0.999. So every time we are approaching very close to what? 1. So x is approaching 1. So this statement can be made like this: x tends to 1. X tends to, that is the easier way of saying it. And the notation is very clear. Now what happens to y then? Where y tends to? What is y? Y is x square minus 1 upon x minus 1. Can I find out the value of y at 0.9? Of course I can find out. See, y is equal to 0.9 square minus 1 divided by 0.9 minus 1. Okay, that is possible. So this is going to be what? You are familiar with the formula a square minus b square. So a square minus b square is what? What is a square minus b square? There is a very simple formula you must have learned in 10th standard, that it is in one bracket a minus b and in another bracket a plus b. Correct? So here a is 0.9 and b is 1. So therefore, there are two factors. One is 0.9 minus 1 and the other factor is 0.9 plus 1 divided by 0.9 minus 1. Now 0.9 minus 1 I can cancel because 0.9 minus 1 is just minus 0.1 and this is also minus 0.1. It's a real number, right? And two numbers coming in numerator and denominator will be cancelled. Only if they are 0 they cannot be cancelled. But now I can cancel them. So my answer turns out to be 1 plus 0.9. So my first answer is 1.9. 1.9. Correct? So when x is 0.9, y is 1.9. Correct? Now, when x is 0.99, what happens? When x is 0.99, so let us remove this and let us substitute 0.9. Correct? So it is 0.99 ka square minus 1 divided by 0.99 minus 1. Can you see it clearly? Yes. Now, let us remove this. Previous calculation can be removed. Now, let us see. What happens here? Same calculation. It is 0.99 minus 1 in one bracket multiplied by 0.99 plus 1. And in the denominator you have 0.99 minus 1. And this 0.99 1 get cancelled. And we arrive at an answer 1.99. So when x is 0.99, y turns out to be 1.99. Now, there is no need of calculating further because now we got a trend here. So this is 0.9, this is 1.9, this is 0.9, this is 1.99. So if this is 0.999, the predicted, the next value will be 1.999. Here the next value will be 1.9999 and this will go on. Now 1.9999, this is very, very close to 2. So it is very clear that the numbers here are approaching 2. So y tends to what? 2. So predicted value of this function at 1 is what? 2. But actual value doesn't exist. But I got a predicted value. So PV of fx, PV of fx, predicted value of fx at x is equal to 1, is 2. But that kind of English is not good for mathematics. We have to represent it symbolically. It's better to use symbols for that. Okay, so let us see. Okay, now the same statement can be written like this. In mathematical language, it means limit as x independent variable is approaching 1, then y is approaching what? 2. Then y is approaching 2. So limit of y as x tends to 1 is 2. So limit of y, actually it's a predicted value, but now we forget the word predicted value because we know now what the limit. So limit is nothing but a prediction. It's a prediction based on the observation of function nearer the value at which we are going to predict. So there is a limit. So I can say like this, limit of x square minus 1 divided by x minus 1 as x tends to 1 is equal to 2. In other words, we have actually solved the problem of division of 0 by 0. So this function What will happen if it actually reaches 1? It is going very close to 2. It's a different matter that at 2 it fails to reach that value, but predicted value tells us that it will reach 2. So that is a very useful information, because now we have solved the problem of division of 0 by 0. Because I put x is equal to 1 here, I get 0 by 0. So there is some kind of an explosion and I am helpless. But now I got an answer to this. Okay. So this is the concept of limit. Okay. So now, if you have any questions, you can always direct them, on the below, right? Below the comments. And if you have not understood anything, you can always say or tell me what is it. Now, remember, I said in this diagram, I said x approaches 1. Now, all the values that I have taken here are to the left of 1. That means, essentially, I am going to approach 1 through left-hand side to right-hand side. Correct? So, my direction of approach is like this, from left to right, from left to right, from left to right. From the values which are less than 1 and they are approaching 1. So, actually speaking, this is a left predicted value. So it is not actually predicted value, it is called left PV. Why? Because essentially we are approaching 1 through the value of x which are less than 1. All these values, this is less than 1, 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 right? But on a real line, is that the only way of approaching 1? No. You could have approached from this side also, right? So you could have approached this. So this approach is called what? From right to left. So, and the values that you are going to take here are like this, 1.1, then you will take 1.01. So you are approaching 1 from the other side. So there the values will be 1.1, 1.01, 1.001. All these values are greater than 1. All these values are greater than 1. 1.0001 greater than 1 and so on. In this case also, y will take the same answer. Y will become here 2.1. Here it will become 2.01. Here it will become 2.001. Here it will become 2.0001 and so on. So on this side also it is approaching. So if you take this from this side to this side, then its right approach is also what? Same. It gives you same answer, 2. Here x is approaching 1 from values greater than 1. So that is the left predicted value, correct? So left PV is already 2, okay? But these values are what? They are right PV because we are approaching from right side. Essentially, values right side means values greater than 1. Okay. So we are approaching from right to left. Correct. So from right to left, this predicted value will be called right PV. Right PV, right side predicted value, that is 2. But left predicted value and right predicted value is same, correct? That is the requirement of limit. The answer of limit should be independent of approach. Whether you approach from left or from right, the answer must match. Then only we say limit exists. If they do not match, the limit does not exist. So limit exists only when, now let us remove the word predicted value, we'll call it left hand limit. And we call right hand limit. So whenever left hand limit is equal to right hand limit, then only common value will be called limit. Otherwise, the limit as such does not exist. In the same way, the actual value did not exist, even limit may not exist, because the approach from right and approach from left gives you different answer. That is not acceptable. I think this is clear. So I'll write it technically. What does that mean? That means limit exists when it is independent of approach. That is, left predicted value, left PV, LPV should be same as RPV. Now, LPV means X is basically less than that number, right? X is less and here X is greater, right? Now, in both the cases, the answer should be same, right? But this predicted value is my invention. In mathematical terms, it means limit. So, I'll say left hand limit. Left hand limit. Left hand limit. That means X is approaching 1, but only from one side. So, since I am approaching for 1, I'll indicate that approach by writing this bar on the top of 1. It's a minus sign. But remember, this minus sign has nothing to do with the normal minus sign. This minus sign has been used to indicate approach of X towards 1. If it is approaching from one side, I am going to call it 1 minus. Okay? And if and that is called left hand limit. So, LH limit is a left hand limit. Now, there is something called right hand limit. Right hand limit. Now, right hand limit will be denoted like this. Limit when X is approaching 1, but from which side? From right side. So, I am going to put a plus sign on the top. This plus has nothing to do with ordinary. It only means that X is approaching 1 essentially from the right side. Means X is always taking values which are greater than 1 but very close to 1. Okay. So, here the values are very close to 1 but greater than 1. Here the values are very close to 1 but less than 1. So, this value that we got was a left predicted value. This is called right predicted value, and this is called left hand limit, and this is called right hand limit. Now, limit exists only when the left hand limit is equal to right hand limit. Okay, that is the basic concept of limit. Is that clear?